skills that you need to know when you're approaching a design job that is either on screen, in print, or both. I'm going to start off with a discussion around the resolution that we use in both of these places. And then I'm going to review a little bit about color formats. I know we already talked a little bit about it when I first talked about color at the beginning of the semester, but just to kind of review and reinforce what we talked about. So at times you're going to notice that print and screen will use almost like two different languages to talk about the same concept. And resolution's a great one for that. When we talk about print, we talk about DPI. We talk about dots per inch. And when we talk about resolution on screen, we're talking about pixels, so we're talking about PPI. So even though in both cases we're talking about resolution, we use different terms. In the same way that we've already looked at, that we use a different color process when we're working in print than when we're working on screen, that one is based in light and one is based in ink. So let's talk about that ink. DPI is often used kind of as the default for what we talk about. And I think that's because, in a way, it kind of came first. When we think about original dot matrix printers, they literally had a grid that they were filling out, and they were deciding, does this box in the grid get colored in or not? So DPI is how many dots there are in each inch. So if you are going to a printers where they actually make prints, you can have very, very high resolution. And so you can almost think of it like the mesh on a silk screen. That the finer the mesh, the more dots you're getting, the more ink that's being spread. If it's a chunkier mesh, then you're not having as many dots. The resolution isn't as fine. You can see the differentiation. So standard, in every inch of printed material, your own printer at home, your printers for the output if you are going to get a poster printed, the standard that we work with is that you want to be looking at 300 dots for every inch. Now, we do have printers that output higher, especially, again, if you go to a professional printer, but 300 DPI is the industry standard. So this you need to keep in mind when you are bringing in an image from a photograph. If you're scanning something, if you have something that's small and you know that you want to blow it up and make it bigger when you work with it, then you're going to want to scan it at a higher resolution, because if it's 1 inch big and you scan it at 300 dots per inch, then it has to stay 1 inch big or be smaller. If you scan in something that's 1 inch big, but you know you want it to be 3 inches big, then instead of scanning it at 300 DPI, you need to multiply that by 3. So you'd have to make that, instead of 300, 600, 900. So you need to make it 900 dots per inch in order to blow it up and still have it look good. So just remember, print 300 dots per inch, 300 DPI. And that's going to be true whenever we're doing a physical output, whenever we're printing something out. Now, by contrast, when we're working on screen, there are much fewer dots going on. So our dots in this case are not dots of ink, but they're pixels. And so remember, each pixel being this little mote of light that's made up of your 3 colors. So when we're working on screen, we actually have far fewer pixels per inch than we do the dots that get printed out. Now, our resolution on screen goes up and up and up with every year, but we still work with either a standard of 72 or 150 pixels per inch. Now, the reason, again, you might want to go with 150 is that we do have screens getting bigger and bigger and bigger. So it used to be that you would be working in standard resolution. Now everything's high definition. So if you want to make sure that the image that you make when your screens get bigger doesn't get tiny, 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 you can work kind of double size. Obviously 150 isn't quite double of 72, but it's a little bit easier to work with in our brains. So we use pixels when we're on screen, we use dots when we're on ink. one dot approximately equals 1 pixel. So you can kind of work back and forth. But if you hear someone saying DPI, someone saying PPI, just make sure you understand that dots are dots of ink, literal physical dots of ink, and P stands for pixels. In both cases, it's how many of those little dots there are for each inch of either your screen or your physical output. Also, always keep in mind that there are going to be changes in terms of resolution on screen, so always stick to whatever best practices are in your industry or anything that you've been given. Again, if you're working on a game that maybe people are getting ready for, 4K TVs, then they might want you working bigger. Whereas if you're working for a mobile app, then you might want to work smaller. So refer to whatever specifications you've been given. But as a rule, 300 for print, 72 for on-screen. And I just want to keep reminding you that you can always make things smaller, but you cannot make things bigger. If you scale things up, A, I will notice, and B, you will lose points. So please, please, please don't make things bigger. I know that it is, you kind of want to. The temptation is always there. But it doesn't look good. Or you have to work so much harder to make it look good than you would to maybe either choose another image or spend a little bit of extra time to find the original or scan it in yourself. So when in doubt, work bigger and then make it smaller. So again, when we're talking about our project where we're making both print and on-screen media, one of the reasons I want you to start in print is then you're going to have all of your elements as big as you need them, and you can always make them smaller for screen. But you do not want to be working on screen at 72 pixels per inch and then have to triple the size of something to 300. It's not going to look good. It used to be an issue around the speed on your computer and size, but now we have so much speed, we have so much memory in our computers, there really isn't an excuse not to be working at the size you need. So for your slides, a little cheat sheet here, and in all of these, you can kind of go to the slides with the darker background for the light breakdown. Again, print 300 DPI, screen at least 72 DPI, PPI, see? And there's 1 dot for every pixel. Now, I just want to review color space. So we've already talked about this, but I just want to remind you that again, in the way that we are printing out physical dots versus looking at on-screen pixels, the same goes for our color space. So remember that when you're working in print, you're going to be using pigment, you're going to be using ink, and so that is a subtractive color model. When you put all the ink on top of each other, it makes black. It makes a void. So the more ink that's present, the less light is present. So standard print color, cyan, magenta, yellow, and black. The K is for black because B is used in RGB already. So we've got our blue, we've got our pink, we've got our yellow, and then we've got black. So all ink-based systems are subtractive. Not all subtractive systems are CMYK, but that's the standard. That's what we use. That's what most printers, when we're talking about kind of prosumer, so consumer-based and the lower end of professional in terms of cost, that's what you're going to be using. So that's the standard that we're going to be working in. So this, again, is what it looks like when you print all of the colors over each other. In contrast, when we're working on screen, when all of the colors are present, we get white. So again, each time you turn a pixel on, there is more light present. And so they add up and you get white. So that is for your screen. That's red, blue, green, your primary colors. And so that's how we're going to be working on for our on-screen pieces. So for your social media work. Because we are working on a computer, for the most part, our programs are going to default to using RGB. So that means that when we look at setting up our document in Photoshop, you're going to need to specify that that is for print and so needs to be in CMYK. If you don't, it'll be in RGB, and then your print will not be right. You'll wonder why the colors don't look right, why something looks really bright on screen and it comes out printed all muddy, and it's because you're in the wrong color system. So always remember to check what color mode your document is in. And when we look at Photoshop and the layout, I'll show you where it tells you that on the name of the document itself, and where you can change that if you haven't set it up from the beginning. So again, here's an image that shows you what happens when you put all of the colors of the light together. You get white. So remembering that we need to specify in our app, in this case Photoshop, what we want to be doing in terms of color mode. I do want to mention something that didn't come up when we were talking about color before, and that has to do with when you are professionally printing. There are times when you're going to go to a printer and for either cost reasons or because of a particular look that you want to achieve, instead of using your standard color format of CMYK, you're going to specify that they use specific inks. So easiest example, a thing that you'll have come across already, is if you're getting a t-shirt made. So oftentimes t-shirts are made through a silk screening process. And in that case, every single color is printed on its own screen. You can do the same thing when you're printing posters, when you're printing anything really. And oftentimes it's become less of an issue around cost because it's become so affordable for us to print out in large quantities digitally. But you might want to, for example, black and white printing is often cheaper. Well, if you wanted to do black and white and then just add one other color to it, oftentimes that's cheaper than doing a run that's in full digital CMYK. So there are times when you're going to be using that thing where you specify the color. So that is called a spot color because you're oftentimes using it in one spot. So that's where the term kind of came from. So I just want to mention that that is something else you might come across, and so not to be kind of confused by it. And it can be used to create specific looks as well as for cost purposes. So that's another type of ink-based system, because there is no real advantage to doing it on screen unless you're doing it for a look, because it's not like it costs more to have more colors when everything is made up of pixels. So this is more having to do with when you're printing and printing only. You will notice that, again, in professional settings, you might have heard of Pantone before. Pantone is the most popular, most widely used, and one of the oldest color matching systems. And with Pantone, they're very specific about the colors of the ink. And these Pantone inks are the same no matter where you go to get them printed, no matter when you get it printed. It's the exact same color. It's very exacting. And there are books out there that you can go through, and they're little, like, you can kind of fan out the colors in terms of picking which Pantone color you want. And there's also conversion charts that will convert it into an RGB color and also convert it if you need to print it out on a CMYK printer. You might notice, for example, that when I gave you the colors for AIC yellow, that there is a PMS color, and then there's the CMYK, there's the hex, and there's an RGB value. And so in this case, you have your Pantone color matching system. That's PMS's Pantone matching system. Then you have your cyan, magenta, yellow, black. You've got your red, green, blue. And then your hex code is a specific hexadecimal code, and that's basically used by web browsers because web browsers, that's the type of code they use. So this way, you know that that color is going to come out the same no matter where you use it because this conversion has been done. In terms of making an effect using limited colors, you can also do what's called a duotone. So a duotone means that you've basically only using two colors. You're not using black, you're not using any other color but these two colors, and you're overlapping them in order to make an interesting kind of overlay of these colors. And it can also save money. Again, as I was saying, if you're just using 2 colors in printing, that may be a cheaper option. But it also looks kind of interesting. And so in this example here, I haven't done a true duotone because, as you can see, I've got the red and black in there. I was kind of doing this on the computer in order to simulate it because I was interested in the tonal look that I got from doing this. So in the center circle, the duotone is between this deep blue and that kind of yellowy color that you can see as the main color in the main image. And then it was switched. So it's actually a slightly different shade of blue. It's kind of more of a purple in the main image because I could get away with this because I was cheating and just doing it on screen. But the main image has that yellow as its main color, and then that kind of purpley blue color is the shadows. And so what it does is it basically says, okay, anything for a value of white is going to be this yellow. Anything that's a value of black is going to be this other shade of blue. And it makes some interesting tones. And it's not quite a sepia. It's not obviously quite a black and white color. There's an interesting intersection between how these 2 colors overlay and overlap on each other. So that can be a way of actually using a limitation in order to make something more interesting looking visually for the eye. And again, just reminding you that if you are going between different color sets, make sure that you do a proper conversion. If you just change the mode, you'll actually see it in your documents. The colors are going to shift, so you want to make sure that they match. So I just want to end again on your cheat sheet page. So just recap one last time for you that print, 300 dpi, CMYK, pigment, subtractive, ink. RGB, light, screen, 72 ppi, anything that's light-based. We can sometimes work in other pigment systems that aren't CMYK. All pigment systems are subtractive. CMYK is a pigment system, but not all pigment systems are CMYK. You can specify colors to a printer, like a large professional print operation, and they will be able to match that for you. It's different mixes that you specify. So remember these guys. It is very important because, as I was saying, when you do change between modes, you'll see it. The colors will shift, they'll change, and you don't want to be surprised, and you especially don't want your client to be surprised by the way a color turns out because it was incorrectly specified or incorrectly proofed to them through the documentation that you're sending them or how you've displayed it to them before they see the final result.